enough.
All right. So again, this is electrical area classification. The bulk of this course actually talks about um, the material, the rules, right? The rules
Hmm.
for identifying different classifications. So we'll look into area classification terminology and the standards. We'll talk about identifying electrical equipment that can be used in different hazardous areas. And then we'll introduce you to that PIP ELEHA01, which is the piping and instrumentation plans or whatever that is. I can't remember. And then that standard, it's a standard actually. That standard actually breaks it down into Form 1 and Form 2. That's what that is. So if we look at the world, I don't know if this has changed or not. It's still the Gulf of Mexico, even though Trump thinks it's the Gulf of America. Anyway, so this red part right here is the NEC, right?
Yeah.
So we follow the National Electrical Code. The Canadians, they follow the CEC, which is the Canadian Electrical Code. They're super close together. I mean, they look almost identical. Stenelec, the Stenelec right here is CE or ATEX. That's the UK. I don't know if this is
Okay.
spread out or not, but and then you have right here is all the yellow pretty much follows IEC, Cenelec, or NEC. It
Hmm.
depends, whatever they want to follow. So I've done jobs down in Brazil and they were happy with NEC. I've done jobs in Canada and they were okay with the NEC as well, right?
Okay.
Australia has its own whole bunch of other codes as well, just so you know. So in our job, if I was to look in the Burns McDonnell Max Central, right? I would find section 16111. If I type that in, section 16111, conduit and accessories. And in there, these specifications, we usually attach these to different projects we're working on. You might also find the client's specifications will say this. And
Hmm.
somewhere there should be some job condition, right? And it'll say all work, including equipment and materials in hazardous classified locations, shall conform with NEC. And hazardous locations are Class 1, Div 1, Group B, hydrogen. It's a hydrogen storage area. Class 1, Div 2, Group D. This is just examples. This might be something that you actually see. And then when you have Class 1, Div 2, Group D, they might have an oil storage area or a methane natural gas areas. And then here's their hydrogen storage area. So this is just an example of that specification. We actually write these specifications as well.
Hmm.
So you'll see, like if I looked into a Emex job or something like that, you'd find my original specifications I wrote. So in order for you to light a campfire, right, for a fish fry or something, um, what do you need? How are you going to get the fire going?
Um, or like air, most likely, right?
Yep, you need air. What else do you need?
I mean, I need yeah, gas also, or
Fuel. It could be
coal.
wood. It could be
Yes, wood.
coal. It could be charcoal. It could be uh, a can of propane, a bottle of propane. And then you need some type of energy to ignite it all, right? You
Hmm.
need like either a striker, like a flint, or you need like a one of those things that you
Sparks.
spin and it makes sparks, right? Or
Hmm.
a lighter or something like that. So the same applies to an explosion, right? If I'm gonna have an explosion, these things have to happen.
Hmm.
And if I want to prevent an explosion, I must pull one of these things from it, right? I'm not going to pull my fuel, gas, vapors, and dust. That's the problem. They exist. I'm not
Hmm.
going to pull air either, right? Can't suck air out of the area. I guess I could if I was doing a pressurized panel and if I purged it with nitrogen or something. And
Yeah.
energy, as far as energy is concerned, that's what I'm after really as an electrical engineer.
Mhm.
So the NEC is broken up into different sections of Article 500. You've got 500, you've got the definition of different hazardous locations. 501, Class 1 locations. What are Class 1 locations? You remember?
Um, Class one locations were I don't remember honestly.
Gases and vapors, right?
Yeah,
Gases
gases
and
and vapors.
vapor.
Yes.
Class 2 locations are dust.
Uh, okay.
Dust. Class three is like flyings and fibers in a like a industry like where they sew and cut material and stuff like that, or in a
Hmm.
sawmill. Intrinsically safe systems, intrinsically safe. That means that the amount of watts to actually open and close something or to open, that's, a switch is turning on and off. The wattage of it is so low that it can't ignite the power. It can't ignite the
Oh,
environment, right? It can't
okay.
and create an arc. Then you have 505. In 505, they actually merged the division system with the zone system. They made it harmonious, right? And they did this in 1996, actually. But class one, zone 0, 1, 2, and locations, right? That's what 505 is about. 510
Hmm.
is hazardous location specifics. 511 is commercial garages, right? If you had an auto shop or something. 513 would be aircraft hangars. 514 gasoline service stations. 515 bulk storage plants, and then paint booths. Paint booths are highly explosive.
Oh,
So
okay.
again, we have the class locations, right? We have class one, vapors and
Yes.
gases. Class
Hmm.
two, dust. That's a
Must.
big, yeah, this is actually a big wheat facility, right?
Okay.
Whatever, a wheat silo. Class three is fibers and stuff like that.
Mm.
So in NEC Article 500 dot 5, I'm going to close that. Let's see if I can move this guy around. Oh, I can't. An area where flammable gases or vapors are or may be present in the air in sufficient quantities to produce an explosion or an
Mhm.
ignitable mixture. How much is sufficient? It's a good question, right? We'll get
Yes.
into it. So here we got class one locations. We've got this rig. Pretty much everything on is class one, div two, or div
Hmm.
one. They've got a flare, that are burning gas off. Any area where flammable gases or vapors are or may be present in the air in sufficient quantities to produce explosive or ignitable mixtures, right?
Yes.
So, and here's a typical, you know, GE turbine installation. This would be like Tico. We did a big Tico job there. And when you look at it, you've got a big old rotating generator, on this
Hmm.
particular job. So you got one is your turbine enclosure. Where's one? Right there. You got two is your exhaust and duct. Three is your cooling water module, wherever
Hmm.
three is. Do you see it? Probably there.
They're out there. Yeah.
Yeah. So then you got four is your exhaust stack. You got five is your CO2 fire protection skid. So this thing
Mhm.
is a fire protection skid. You got a water injection skid. You've got a liquid fuel atomizing air mixed module. Seven. That's probably liquid fuel. It's probably your
Mm.
natural gas, right? Propane, the main accessory fuel gas module. Eight, right? So between these two, there are definitely some issues there, right? You got
Mhm.
your PECC. I can't remember what that is. I just drew a blank on that one. I don't remember.
Mm.
Your static start equipment, your BAC. I can't remember that either. It's been such a long time. And then your air inlet housing. So my point is, one, on the one where it says the turbine enclosure, if you have a turbine enclosure or a generator, right, somewhere in there, what's happening is this actually can be filled with hydrogen
Mhm.
because it keeps that generator cool, right? So you
Yeah.
got to watch for that as well, right? But definitely, I would say without a doubt, seven and eight are classified for sure, right? So here we have a
By the way,
hydrogen. Go
sorry to
ahead.
cut you. PEECC is packaged electronic and electrical control compartment. Is that
There you go. That's your
maybe?
build. Your
Okay.
maybe your start stop building, and
Mhm.
what's your BAC?
Give me a second. Uh,
The acronyms. That's one thing that
yeah.
when I came to Burns McDonnell, it was the acronyms that killed me, right?
Yeah. Yeah. I can't find it right now. But
Doesn't matter. It
I'll
doesn't
keep
matter.
looking.
Yeah, it
Uh,
doesn't matter. So you got class one locations, gases. So here we have a hydrogen dryer used for the SFH2 generator. So they dry the hydrogen, right? And so
mhm.
this pump is full of hydrogen, right? And this box, what kind of box is that? It's an electrical box, but what kind is it?
Is it a termination box? Oh,
It's an explosion proof box. That's what I was looking for.
oh, okay.
But it could have a motor starter in there, all kinds of things. But do you see something wrong with this thing? If I zoom in real close, oops, where did I go? I try to zoom in. You see that little doodad on top of this guy?
Yeah.
That's a capacitor.
Oh, okay.
And
Okay.
that means that this is a single phase motor. So if I was going in there and I started looking at this design, I'd flag that electrical connection right there. It looks like a little flexible connection. It
Mm,
should have a special type of connection. I'd flag that single phase motor. And, obviously they're still doing construction. So there's other things. So it has to be rated for that environment. So you see class one locations, gases, and these are the
mhm,
different areas you would see them, right? Natural or liquid gas storage facilities, chemical plants, petroleum refineries, et cetera, et cetera, et cetera, right? Then you have dust, right? These are dusty locations. And this
mm.
particular one right here looks like maybe it's a sugar or a wheat meal, right?
Okay.
And you can also have different types of levels of dust, right? Or types of dust. F would be like a plastic or something like that. But this
Mm,
wheat right here, it's highly ignitable. It's like sugar mills and stuff are extremely ignitable, right?
okay.
So an area where presence of combustible dust presents a fire or explosion hazard. What would you do to get rid of the dust?
Mm,
Clean it, sweep it, right? You
yeah.
got to, or you have a dust collection system where
Yeah.
you actually pull the dust off of there. You're moving so much air in an area that it collects into a dust bin, like these things. Maybe they're dust bins. I've
Okay.
seen that as well as. So where would you see a class two industry? Grain storage, coal storage, metal grinding or metal powder
Mm,
producing facilities, gunpowder or explosive firework plants, sugar, coca, spice, and starch production, right? These are the things you
s-
might see that. And then a class three fibers, right? So you have an area that's made of hazardous areas. This picture is not the best one. I don't know why I picked it. I probably copied it from something. But really, a fiber or flying would be more like a textile mill, right? Something like that.
mm,
So you got cotton, textile, or flax producing or handling facilities, wood cutting, pulverizing, or shaping plants, clothing manufacturing facilities. That's where we see a lot of people uh, they die because of
mm,
the clothing manufacturing catches on fire. So we know what class one and class two and class three is, right?
mhm.
Class
Yes.
one is what?
Gases and vapors. Class
Class
2 is
two,
dust.
class three,
Is flying fibers.
right? So then, if that if that explosive mixture is there all the time, guarantee it's there, right? Then
Mhm.
it's a div one, right? That's a div one location.
Oh,
If
okay.
it's not normally there, but it could be. In fact, it could be from 1 to 10 hours a year. It's possible, highly probable there could be that mixture in that area. It's div 2.
Okay.
If it's less than 1 hour, it's general purpose, right? So a
Okay.
div 1 is anything greater than, 10 to 1,000 hours, right?
Okay.
If it could happen that it's 10 or 11 hours all the way to up to 1,000 hours, yeah, it's there, right? So those conditions could exist. So you get div 1 locations. Again, it's in the NEC Article 500.5B1. C or D. And it says here an area where the hazardous exists under normal operating conditions. This also includes locations where the hazard is caused by frequent maintenance or repair work or frequent equipment failure. So, a frequent area for maintenance or repair, you know what a pig launcher is? You ever seen
No.
a pipeline and they have the
Yes.
device and they have a deal where they open up the back end of it and it's a little bit bigger and they stick a pig in there, they call it, and it's actually it cleans the ID of the pipes. They close it and they put pressure behind it and it scoots down the line, right?
Okay. Okay.
So that's how that works. So again, class one div one would be considering 8,760 hours per year. It is proposed that a div 1 location would be from, 0.1% of the time to 8.76 hours per year.
Mhm.
So it's basically 1 to 10 hours, right? A Div 2 location says, hey, this pipes are pretty well secured. They could leak, but they're not designed, they are sealed.
Mm.
Probably get away with walking around there with a match. I wouldn't do it, but you could. Um, it shouldn't be, it's got the potential to be hazardous, right? And the potential is based on the fact that between 1 to 10 hours, it could be conductive. It could
Mhm.
be explosive. So there could be an accidental rupture or breakdown. Another thing is once you find a Division 1 area, there's always a Div 2 area around it,
Mhm.
right? So a Div 2 location would be one that is within the range of 0.01% up to 0.1% or 1 to 10 hours, right?
Mhm.
It's hiding behind me there. And then here's an example of a Div 1 or Div 2 location. So we have this gas pump. You go fill your car up unless you got a Tesla, which may or may not explode right now as well because people don't like them. Um, it's
Me too.
terrible. Yeah, it's terrible. I actually like them. I've never driven one, but the concept is really cool.
Yeah.
So if you look at this thing, it's saying that you have 18 inches away from that pump, and then 18 inches up, and then 20 feet is all classified. If you're standing right here, it's okay, right? But if you were to get on the ground, you might smell vapors because they're
Okay.
heavier than air. So that's what it really breaks down to. Is the gas heavier than air, right? So
Yeah.
here we have air is one, and actually, to be quite frank with you, it wouldn't be floating. Air would not be floating because the weight of the balloon would pull it down. But you could have a heavier than air gas, right?
Yes.
There's a lot of them out there, and they'll fall definitely to the purposely led balloon in physics. They said, and you'd watch the guy fill it up with xeon or something, then it
Mm.
boom, boom, and fall to the ground. And then here's another one. Inside that, inside this, right, is a Div 1 location.
Okay.
And then you've got the 18 inches and 18 inches, et cetera, right? So all we're trying to do is one, define how do we define it? We know that it's some gas, we know that it's some dust. So we're going to define it by class one, class two, or class three.
Okay.
And then we're going to give it a division number. We're going to say, okay, well, it's Div 1, it's always there, guaranteed 1 to 10 hours or 10 to 1,000 hours of the year or
Mm.
more, it's Div 1. If it's, probably it could be there, a leak source, certainly. Then you're a Div 2. So now the only thing we're missing is what is it, right? If it's Div 1, if it's class 1, Div 1, or Div 2, what is the group? And that's what we're going to talk about now is groups. So you got group A, B, C, and D gases, right?
Mhm.
A being acetylene, B being hydrogen, C being ethylene, D being propane. Those are just examples. And if you pulled up the NFPA 497M 1986, you'd find these all broken out.
Okay.
So groups indicate the degree of the hazard, where A is the most flammable. It's just so explosive.
Okay.
Acetylene. Acetylene bottles actually have cork material in them. And the reason they have cork material in them is if somebody opened up the valve wide open, it prevents the gas from escaping from that bottle and it from real fast because if it escapes real fast, just the action of it leaving that bottle can blow it up, right?
Okay.
That's how explosive it is. And a group B being the next, the Zeppelin hydrogen balloons and whatnot, the
Mhm.
blimps and whatnot, right? So remember we said, and I think it was here somewhere. Let's see. It says here, this also includes, I'll just read it real quick, I just want to show it to you because it's kind of critical. Be present in air in sufficient quantities. Remember we tried to define that?
Yes.
Well, what defines that? In
Uh,
sufficient quantity. It's not
the
divisions.
veg.
No, it's not
Mm.
that. It has to do with how much of the product is in the area relative to air.
Mm.
So if you look, um, um, my dog's big. He's ready to get the Amazon guy. So if you got 81% to 2.5%, that 2.5% is the lower explosive limit. If it's below 2.5%, actually it has to be 25% of that. It'll be general purpose. If it's
Okay.
20, so in a group A, but if it's sitting here at 50%, it's not classified. Well, no, I'm sorry. If it's in this within this bubble, then it's classified. If it's above it, then it's not. But if it's 100% gas, you're not going to ignite it. You have to have air, right? Remember, we
Okay.
had to have air. This is
Mhm.
our fuel. We have to have air. So here's hydrogen is 4% to 75%. Group C ethylene is 2.7% to 36%. So again, what is the bottom number?
This is this is
Lower explosive limit
okay.
or lower flammable limit. What's the top number?
The highest explosive limit.
Yep, it's the upper explosive limit
Mm,
or upper flammable limit.
okay.
Okay. So here, what this tells you is how volatile that gas is. Acetylene rises real fast and then it tapers off. It's the most volatile.
Mm,
Hydrogen does the same, but it doesn't quite build up as much pressure.
mm,
Still pretty tough, right? So these are tests that they did, and it kind of gives you an appreciation for how much pressure it builds up in how many seconds.
okay.
Significant amount. So now we're moving into dusts, right? Group E, F, and G. So before we had groups A, B, C, and D. So if I say class one, group A, B, C, or D, you know what that is. You know that it's a gas, you know that it's a gas or vapor, and you know if it's acetylene, hydrogen, ethylene, or propane.
Mhm.
Now, technically, I'm giving you names of gases, but really there's a MIC value or minimum mixed experimental safety gap number that applies here, and you can calculate that value. We'll get to that in a little bit.
Okay.
So here you have groups E, F, and G dust, right?
Mhm.
So if you have group G, that's cake mix, cocoa, powdered sugar, grain dust, flour, cornstarch, or flour under stress, right?
Mhm.
Under stress being 6,000 volts. I don't know why they would do it, but they would. There must be some kind of a process that uses that, right?
Okay.
A group F is, your solid carbon, your solid graphite, and your other things here. I can't really read this one. What is group G? Um, Agricultural dust, like probably, I don't know what it is. So again, to summarize this, class one flammable vapors and gases
Mhm.
are broken up into groups A, B, C, and D. Class two combustible dusts are broken up by
E, F,
group,
and G.
yeah, E, F, and G. And then class three are your fibers and flyings, right?
Mhm.
Identifying electrical equipment that can be used in the different area classifications. Well, they come in different flavors in the states, and one of them is a UL NEMA 7 or NEMA 9 box. It's a
Mhm.
big, thick, heavy box that allows the explosion to occur inside the box. Go figure. And it won't blow up. Purging and pressurization systems, they push enough clean, dry air or an inert gas like nitrogen into the box so that it'll never get into those ranges where it has enough air to ignite.
Okay.
So here they know the gas can seep in there. They know the box is in the gaseous area, but it's because it's purged, you can't create it, the gas can't even get into the arcing area,
Mhm.
right? And then intrinsically safe areas are you're limiting the energy below a certain value. So believe it or not, these NEMA 7 boxes do explode, but they're still safe. They contain the explosion and they have a cooling effect that by the time it gets outside, it'll actually cool the explosion or the gases, the hot gases, to the point where it won't auto ignite the air around it,
Mhm.
right? The gas around it. So here you have one under test, right? And boom, it blows out. Believe it or not, it really does that, right? And I used to have a cart that I had from, I don't know who it was, some company let me borrow it, and I'd put hairspray in it, and I'd close it up, and I'd blow the top off a little area that was away from the seal, and it was because they were trying to show everybody how volatile that gas really was.
Mhm.
So here, threads matter, right? You can't just put anything out there. You have to use um, equipment with joints that are rated for that environment, right? So either they're flat and they bolt down and that internal pressure builds up, but it cools off, or they go through this flame path until they cool off. It screws
Okay.
down. So it matters. And here's some more different fittings here. They have a
Mhm.
gasket on this one, so that's a NEMA 74X or 4, right? So it's waterproof, right?
Mm-hmm.
And then here you have a
Hops.
reducing joint. It's a
Northeast.
reducing
Okay.
joint. Yeah. REA, I think it is.
Mm.
And it has to have the right threads per inch for the different gases. So if it's hydrogen, you have to have a different gas, a different REA, reducer joint from a group D or C, right?
Mm-hmm.
That's how specific it is. This is a typical, what is
Switch
this?
rack.
Switch
Switch
rack.
rack.
So you've used these before. And what are these? What are these things right here?
Mm.
Called conduit seals.
Okay, got it. Yes.
And what they do is they know up here in this bus, it's open. You can, air can get in there, breathes and stuff like that.
Mm.
This guy breathes as well because there's a breather drain device on the bottom of it. There's low point breather and drains on these conduits as well. But this particular seal is filled up. It's supposed to be 40% inside there. If you buy a standard seal, it's 25% fill. But if you
Okay.
buy an expanded fill, then you can fill it up at 40%, which is 40% happens to be the conduit fill for the NEC, right?
Mm.
Unless it's like a multi-conductor cable, one multi-conductor cable, 53% fill, but
Mm.
you can't do that here, right? You have to follow these rules. So the basis is if you have a conduit coming in and a conduit leaving, no matter where it is, they must have seals, or
Okay.
they must be rated for that environment with a safety gland. Here's a light switch. This is an ordinary light switch, but it's designed so that it's in an explosion-proof box,
Mm.
right? So when you open and close it, if there's gas in that area, it will light that gas. It'll
Mm.
explode, but it won't blow your hand off.
Okay.
It'll just ignite it, put itself out. And so here we have inlet air piping running through an enclosure left side. So, you know, it's possible that, I don't know why I picked this picture other than the fact that maybe it has that NEMA 7 box there, right?
Yeah.
So, but if there's a NEMA 7 box, there's something here, probably hydrogen.
Okay.
NEMA 7 designs, the advantages, the explosions is contained. It's containment,
Mm.
right? There's no electronics to worry about. There's low maintenance. There's no moving parts, and you can put high powered equipment in there. I've designed offshore class one, div two rectifiers that were up to 800 amps using
Oh.
a box like that. The way I did it was I machined the outside and I machined the inside. I bolted the SCRs to the inside, and then on the outside, I put a water cooled heat sink that we
Mm.
made. It worked really well. It worked real well. If it's small enough, I can just put a heat sink that's air cooled, but rare, that would be like 50 amps or something, 50 amps or less. So there's no disadvantages. There's no warning mechanism for containment failure. So if somebody forgot to put a seal in,
Mm.
if somebody left the bolts off, you don't know. You know, if they left them all loose. So you got danger to equipment after it explodes. If it explodes, which it will explode in there, if the equipment is not rated for that, or it could hurt things inside there. It could blow a
Oh.
PC board up or something like that.
Okay.
Possibility of installation and maintenance errors for sure. Some people don't understand how to use them.
Mm.
Some people drill holes in them, and then they put their own tap in there, stuff like that. The cost for protection per cubic foot increases, right? These are not cheap. I'm talking like
Mm.
a box that is 24 by 24 could be $7,000 or $10,000, right? They're not cheap at all. Windows are limited. You can only have their approved UL windows. Condensation buildup is common. It is because it's in a box and it sweats because it's
Mm-hmm.
aluminum, right? You can also have a stainless steel box, but it'll still sweat. So that's why we put those drains, those breather drains in there.
Mm.
Problem is if it's a breather, what does it do? It
But
breathes in that environment
yes.
that is classified, which brings in the gas, which causes the fire to explode.
Mm.
So only a few sizes have been chosen. They're very heavy, limited access, bulky design causes harmful heat buildup, and they do, and excessive weight. They're super heavy, right?
Mm,
So here's an example. We have an explosion-proof box here in NEMA 7. We also have another explosion-proof motor starter here. This is how they used to design them. They were circular, and they still see them out there with the
mm,
spin on and off, but it's rated explosion-proof. So if gas gets in here, right, and nobody put a conduit seal here, then that explosion will go down this pipe and it'll build up pressure like the Venturi,
mm,
or a long rifle, and boom, it when it hits here, it'll blow the lid right off this thing. Just literally
mm,
blow it up, right? It's crazy. So you need conduit seals, extremely important. They're required 18 inches from the enclosure, right? If it's 2 inches or larger, conduit enters enclosures that house terminal splices and taps. So um, let's see, required on class one div class one boundary changes, right? What that
mm.
means is if you have a general purpose room, you have a div two room and a div one room, every time you cross that barrier between an area classification
You need to have a
change,
ceiling.
you need to have a seal. And
Mm,
I almost invariably, every time I see these problems, right? I see so many. The depth of the sealing compound inside the seal must be at least 5/8 inch thick, right? So it's the
yeah.
depth of that sealing compound right here. So here's that wool right here that they push in there, right? They open the top of this, they've got the wires all spread out, and they pour the Chico in there. They call it Chico. It's like a
Mm,
paste or plaster Paris. And so the problem is usually they have 40% fill conduit in there, right? They put enough individual conductors in there to meet the 40% fill. But
mm,
the standard seal is only rated for 25% fill. And a
no.
lot of people don't know that, so they'll buy a standard seal and then they'll put a 40% fill of material in there and then it fails, right?
Yeah.
So here's another example. This is more like almost a pat a, resin type stuff. They've kind of
Mm,
changed it up a little bit. Still no different. You see from here to here it has to be 5/8 inch. And the number of conductors coming and going has to be less than 40% fill if it's a standard fill. This is a breather drain. So when condensation builds up in here, it should fall this
mm,
way. So if we have multiple boxes in a room, explosion proof box number one, number two, number three, from here to here, it should be 18 inches. Well, it just happened to be that from this T, that was 18 inches.
mm.
And from this guy, you had an 18-inch seal. So this one from here to here is 18 inches. These are the rules, right?
Yes.
Rarely would you ever have that, but usually you would have a seal, a seal, and a seal, and a seal on the bottom, right? So here's a class one division two location where threaded metal conduits, fittings or explosion fit, they're inside there. So here we have a non-hazardous area out here. We have a class one location here. When it exits this room, we have to have a seal at the
Mm,
boundary
okay.
change within 10 foot of that boundary change, just so you know. These
Mm,
flexible conduits are supposed to be the braided type. They're rated for class one, div one, or div two. They're
mm,
expensive, so some people don't use them in div two locations, and they use flexible cords. It's okay if they do that, but you have to wrap a grounding conductor around it.
mm,
Here we have a general purpose box, right? General purpose receptacle, no seals. It's 12 inches above the class one area. Oh,
mm,
what if it changes? What if this thing fills up with gas, right? I don't know if I would do that. I'd feel uncomfortable with that. And then we have a class one area, and then we have going through there. Seals are not required for conduits that pass unbroken class one locations. So what they're
mm,
saying is because this is in the unclassified area, it goes underground, it's unclassified underground, and then comes back up, then you don't have to have a seal. That's what they're
mm,
trying to tell you, right? But in refineries, it's not uncommon for the ground to be class one div two
mm.
because hydrocarbons are leaked into it. So you got to watch that. This is a motor that is actually factory sealed. You see it? It's got factory seal.
Yes.
So you'll have to see that integral sealing. And then here you've got an internal fan. See that internal fan right there?
Yes.
So this one, you don't have an external fan, it's internal in the motor. And then you've got this heat sink out here as well. This is a typical MCHL, which is metal clad. You also see CLX
Mm.
or MC cable. MCL, this HL means hazardous location, right? You don't have to have it, but you should. It's probably a good idea. If you're using MC cable, use MCHL. But that
Mm.
fitting that they slide over it has to be rated for class one, whatever it is, class one, div one, div two. You're allowed to use a rigid conduit in the States. You're allowed to use steel wire armor
Mhm.
in the States, also in IEC. You're also allowed to use non-armored cable, TCER or TCE. So you can see that this non-armored cable here is allowed in France, Germany, India, Eastern Europe countries, parts of Africa, Middle East, and the Far East. And then this particular cable is allowed in the United Kingdom, Commonwealth countries, and Spain. Everybody hates this cable. It's
Mm.
really, really hard to work with, right?
Yes.
So, but it's rated for it, right? And then here is your actual rigid metal conduit. It's allowed in the United States, Canada, parts of South America, Middle East, and Far East. In my opinion, they're all suitable,
Mm.
right? And most companies accept all of them, as long as they're installed properly. So here you have a receptacle, right? A power receptacle, and it has a special switch and plug, and that way you can plug it in and not create an arc. There are
Mm.
some plugs that when you plug them in, they're not engaged until you push all the way in, then it engages, and
Mm.
you don't need that extra handle there. The switch must be in the off position before the attachment plug can be removed. So these have changed a little bit. Here you've got a horn, right? And a horn can make arcs and sparks. Um, yeah. Let's talk about temperature, right? We talked about class one, we talked about div one, we talked about all the different groups,
Mhm.
but there's also a T rating. And
Oh, okay.
the T rating is called the temperature rating. So the T number is established from the maximum surface fixture temperature in a 40 degrees C and elevated ambience. If the external temperature, surface temperature, exceeds the ignition temperature, then it's a problem, right? So they
Yes.
actually have lights that are rated for certain T ratings, right?
Mm.
And that's another number we have to generate, right? So just to get to this number, so here we have one gas, it's 450 degrees C, it's
Mm.
842 degrees Fahrenheit. That would be T1.
Team.
How would
Okay.
I know what this is? Because this is the auto ignition temperature.
Mm.
Auto AIT, auto ignition temperature. So once you know the auto ignition temperature, then you can figure out what it is. Like
Okay.
a touch screen from Allen Bradley would be a T6. That means it's 85 degrees C, very low.
Mm.
So here you have an luminaire for a class two location. What's a class two location?
It's dust.
Dust, that's right. And then here we have a typical lighting fixture for a class one group A, B, C, D, or it probably says group C and D locations, right?
Mm.
Not all of these are all rated for A and B. You see that a lot.
Mm.
This is what? What is this? This is a
Mm.
purged system. It's a pressurization system.
Oh, okay. Okay.
So, and what it is this gauge tells you if it's in the green, you're in the good zone. If you're low, you have not enough air flowing in there, not enough pressure built up. If it's too high, you can bust a gasket or something and cause
Okay.
trouble. You want to be in the middle of it, right? And that happens to be 0.1 inches of water column. So it's a pressure, it's a unit of measure. This is a Dwyer test switch, right?
Okay.
A differential switch, not test switch, but a Dwyer differential switch. And it measures the differential air from the outside to the inside.
Mm.
And it's saying it's set for 1 inch, 0.1 inch of water column. This particular one is actually rated for the hazardous environment, class one. So this would actually be a Z purge. I mean, a Y purge, right?
Mm.
But you could have a Z purge or something like that. Usually I just buy a general purpose Dwyer switch and I put it inside.
Okay.
That vent is optional. I like them because it always forces air to flow.
Mm.
So an X purge system reduces. So this is all reducing, Here in this previous example, we've got arcing and sparking devices in here, right? We know it, right?
Yes.
And we're trying to put this box that is designed for general purpose in a classified area. That's where
Mm.
this pressurization system comes in. If it's an X pressurization system, and that would reduce or protect the enclosure in a Div 1 or Zone 1 low unclassified area. So that means you can put a general purpose panel with an X purge system in a Div 1 or Zone 1 location.
Okay.
Not bad. If you have a
That's
Y purge, right, you can do a Div 1 to a Div 2. Right? So you can have a enclosure for Div 1 or Div 2 or Zone 1 or Zone 2. It's a general purpose enclosure. I'm sorry, it's a Div 2 rated and components in there. And this one, you have a unclassified general purpose components in the box, but
mm.
yet you're putting the box in a Div 1 or Div 2 Zone 1 location. And in here, you're having a Y purge. So I have type 2 Division 2 or Zone 2 rated components, and I'm putting them in a Div 1 location.
Okay.
And then a Z purge is I have general purpose locations, and I'm putting it in a Div 2 area, right? So you
Mhm.
get that?
Yeah.
Okay. So if I wanted if I had a class 1 um, Div 1 uh, group B P6 gas or something,
Mm.
hypothetically, what what type pressurization system would I need to buy to install that box in that environment?
I believe type Y.
Type X. It'd be type X, right?
Well, we said that I mean
So
because
let me just see. You see this right here? If this was a PLC, like an Allen Bradley PLC, and I looked at the side of this name, it would say it's rated for class 1 div 2. And
okay,
and terminal blocks are rated for class 1 div 2. And this, whatever this is, let's just say it's rated for class 1 div 2. Then this would be, you could put this box by itself with no Z purge system
and
in a
unclassified.
div 2 area. But if you tried to put it in a div 1 area, you would need a Y purge. You see what I'm saying?
Yes.
Okay, so if everything in here is general purpose related, it's unclassified. It's not ready. It has no stickers for any classification.
Okay.
And I'm trying to put it in a div 1 location. What system do I need? X.
X. Okay.
Yeah. So, and now the nice thing about these boxes, right, is you just need to
Sorry,
figure out. Go ahead.
I'm confused from the last yeah, from this slide. So he said
Okay.
if we have all the components inside that they are
Or general,
unclassified.
they're unclassified. They have no stamp saying they're classified.
Okay.
They're
So
general
we
purpose. And we're trying to put that box in a div 1 location. We must buy an X-Purge system. Let me explain how that X-Purge, this might help you. The X-Purge system actually is a little bit smarter. It has a computer in there. And what it does is it says, okay, there's no power on this unit right now,
mm,
right? So I'm going to go talk to the MCC that's feeding the power to this guy. And I'm going to say, okay, I'm going to purge this thing 4 times, right? And each time I'm going to let it go bleed back down. And then I'm going to purge it and I'm going to let it bleed back down. Then
mm,
I'm going to purge it and I'm going to let it bleed back down. Then I'm going to purge it and then I'm going to let it bleed back down. Then I'm going to hold the purge. If it successfully does that 4 times, right? Then it sends a signal back to the MCC that says, okay, now you can apply power.
okay.
That's why you're able to put it in a div 1 location.
Mm, mm,
If it loses purge for any reason, it immediately opens up power.
okay.
Not very cool, right? I mean, you might not want that. So that's how an X purge system works. A Y or a Z purge, they work exactly the same. There's no difference. The
Okay.
only difference is that your internal components are Div 2 rated already.
Okay. I'll protect that.
So
Okay.
because they're Div 2, you can put them in a Div 1 area if it has a Y purge. On the Z purge, because it's general purpose, you're only going to put it in a Div 1 or Div 2 location, then you can use a Z purge.
Okay.
That's the only difference, right? So Here you have supply from enclosed pressurized system. You have clean, dry air comes in here, and it leaves this direction and goes back to that, to the Dwyer system.
Mm.
So you can have multiple size boxes stacked up like that. I don't know if this works or not anymore. Let's see. Probably not. Probably an old. It used to be Bebco. It's now Puffer Schweiben bought Bebco.
Oh, okay.
So that's how long ago. So, but you can go smaller to bigger boxes. The last box has to be the biggest box. So here I could have my air comes in here, goes to the
Hmm.
top, leaves here, goes to the top, leaves here, goes to here, and that's where my Bebco system is. My
Hmm.
purge system is only on this one, right?
Okay.
So you can actually combine these up to 450 cubic inches. Purge designs, obviously the advantages are reduces heat buildup. I don't believe that. It's might a little bit, but not anything significant.
Okay.
Inhibits metal corrosion, low maintenance. Well, how does it inhibit metal corrosion? Because
Um,
it's clean, dry air.
Air. Okay. Okay.
Clean, dry air. So that means that there's no moisture in there being blown
Okay.
in there. It keeps it dry in that box. And so all the pieces, parts and pieces, after 20 years, you open it up. If it still worked, they look like they're brand new.
Mm.
They're so clean, right? Low maintenance, really is low maintenance. You don't really have to do much to them, except for that X purge system that has that little computer in there. You might have to check
Mm.
it. Increased equipment longevity, that's fact because it's clean, dry air. No special enclosures required. It can be some odd shape, sphere, or whatever, as long as it doesn't exceed that 450 cubic feet.
Mm.
Allows fast access to the equipment. That's a fact. If you sweep around it, sniff for gas, as long as there's no gas in the area, you can open up the box if you have a hot work permit, right?
Okay.
Allows reduces moisture and dust buildup. That's a fact
Hmm.
because it never can get in there. Reduces classification within the closure. That's true. One division, one classification, not
Mm.
two, right? Um, except for an X purge reduces it all the way to
Hmm.
from a div one all the way to general
Non-classified.
purpose. Yeah,
John.
because it does that. It has no electricity. It has no power.
Mm.
Um, Continuous status of indication, so you get feedback all the time. That's a positive. Allows use of any enclosure shape. Cost of protection per cubic feet decreases with enclosure size. That's a
Mm.
fact. No immediate danger if system failure occurs. That's true too, except for an X purge system. You don't want to have an
Mm.
X purge system lose failure. If it fails, it has to trip that breaker. Has
Mm.
to, you know. A disadvantage contains moving parts, requires instrument air supply. Some systems require electronics, and you need hot permits. This is an intrinsically safe barrier. And the way this works is it limits the amount of energy that can go out into the field, right?
Okay.
So here's your non-hazardous side inside the box, right? This is your intrinsically safe set area outside the box. These Zener diodes, these are Zener diodes, Z1,
Mm.
Z2. They usually, when you buy them, you say, okay, I want a Zener diode for 24 volt DC. If it gets over 24 volt DC, I want it to clamp it, right? And
Mm.
so what'll happen is if this guy for some reason goes to 30 volts DC, this will never exceed 24.
Mm.
And then you got a resistor, and this will never exceed 24. Maybe it's less. Maybe it's zero point 0.7 amp, whatever it
Mm.
is, right? So basically, what you're trying to do is allow a switch out here, open and close, right? In a hazardous environment that does not ignite because you limit the amount of current and voltage.
Mm.
You limit the wattage that's even capable of being there. It works great for simple things, but it doesn't work great for things that require power. So the
Mm.
only protection allowed for zone zero. Zone zero is the most strict of all. Can I take a zone zero and put a div one location, a piece of equipment in it?
No.
You cannot. Can I take a zone zero and put it in div one location?
Still no, right?
Yes, it is yes. Zones outweigh divisions for whatever reason.
Okay.
Eliminates possibility of explosion, no hot permits, low maintenance, no special cables, ideal for low power devices. It's the only thing that it works for. Limits energy to the device. Disadvantages, obviously, it requires documentation on the IS circuit. You have to write down and test it every so often. I can't remember the time. It always changes. It could be 30 days, could be 90 days. Can be used with low power devices. Can only be used with low power devices. See, here they say it's ideal for low power devices. Yeah, it is. That's an advantage. But the disadvantage is it can only be used with low power devices. So here we have a garage, commercial garage where somebody's, changing oil, working on cars, whatever, right? And so they have in this thing at 18 inches, they have no openings. They have unclassified area here. They got a stock room here. They have an unclassified room here. The door seal, I think this says the door seal is what? Can you read it? It's
Not
probably,
than 18, not exceed that, not more
yeah,
than 18 inches.
yeah, it's not like right there, right? It has to
Mm,
be way down there. So transfer of class one liquids or gaseous fuels required for repair area here. So that means that 18 inches to the floor is classified. 18 inches from the ceiling is classified if it's
mm,
lighter than air gases. Like if you had a natural gas device in there or something like
mm,
that. And then you have a pit or depression where things could drain into.
mm,
That would definitely be a class one div one location, right?
mm,
So if we add 4 air exchanges per hour, so we have at least 4 exchanges up here. We have at least 6 air exchanges per air in the pit area. So we put a little
mm.
vent here and we're moving 6 air exchanges down in the pit area. And here we're moving 4 exchanges. Then this area right here becomes general purpose, but we still have a div 2 location in the
Mm.
bottom of it. Can't get away from that, right?
Yes.
So here we have a tank. We have some vents. We have a fill pipe, right? Because it's a fill pipe, that means I have to connect something to it. And because I have to connect something to it, it's a maintenance issue, right? It's a maintenance connection. And
Mm,
therefore, it's a div 1 location. The red is div 1 and it goes out 3 foot. The Then you have a 5 foot radius here as well. It's kind of a funny looking picture because they don't have it centered over these things, right?
yeah, true, true.
It's kind of goofy looking. But and then they have 18 inches here and 18 inches all the way around it.
And
So
what
here
about
we go ahead.
the bread circuit that is underground? That, like
It's a
there's like a
sump. It's below grade, and above it is a class one div two cloud,
okay, okay,
right? If that sump was right here, it would just be a sump. It'd
okay,
just be a ditch, right? But if that ditch or that sump is right there, and right above it is a div two cloud, then it's div one
okay.
for heavier than air gases, right? So here are these charts, right, that we look up, right? So if I look at, you know, acetic acid, it's a class one division group D. It
Okay.
tells you what it is. It is type two. Well, we don't really care about type two. We only care about, D in this case. And
Mm,
because type one, type two, it seems kind of goofy here. Why does it say
mm.
type one, type two? Acid. Oh, it's not a dust.
Oh, okay. Yeah, that's true.
Type is used to designate if the material is a gas, flammable liquid, or a combustible liquid. Huh,
Okay.
okay. So it's telling you that. And then it gives you your flash point is 43 degrees C. Your auto ignition temperature is
Mm,
464. Your lower explosive limit is 4%. Your upper explosive limit is 19.9. Your
okay.
vapor density is 2.1. It's heavier than air being a vapor density of 1,
Hmm.
right? So that means I have to use the figures and things for anything heavier than air. The vapor pressure is 15.6. And if I was dealing with zones, it would be a 2A,
Okay.
right? And then you see this MIE, this is minimum ignition uh, energy, 0.37.
Yes.
MIC is what? Minimum ignition something, can't remember. And this one's minimum extension or experimental safety gap. These ratios, if I use these ratios, I can determine if it is a group A, B, C, or D.
Okay.
We'll see that in a minute. So it says here that contains additional data on MESG and group classifications. So we'll get to that. So anyway, again, we're going to look at this area classification study, quick review, right? So here, this is an actual PIP standard. And the first time I saw the PIP standard was at Burns McDonnell. Unbelievable. I was like, that's a cool standard. And I latched right onto it, right? I thought that's the coolest thing because you can fill it out, you can follow it and just go right through it, right?
Yeah.
So you have the introduction, you have the references, you have definitions, you have general section of the code, right? You've got class 1 materials, class 2 materials, classification alternatives, right? General pressurization, equipment location, vapor type walls, things of that nature. So here we have for class 1 division, we follow API RP 500 or we follow NFPA 497. You really want to pick one or the other, right? If you start picking them both, then it gets a little muddy, right? Because in my opinion, NFPA 497 is bigger areas, right? More conservative. If I have a class 1 zone area, then I can use this ISA TR 12.2401. I can use the API RP 505, and I can use NFPA 497. If I've got a class 2 division system, which is what 2 is?
2 is dust.
Dust. Then I'm going to follow NFPA 499. Okay. So the objective here is to fill this sheet out, right?
Okay.
So if I had hydrogen, what is my air density for hydrogen?
I don't remember, but it's going to be heavier than air, right?
Lighter than air.
Yeah,
Remember?
true.
Yeah.
Lighter than air, yes.
So if I exited this, let's just see if I can find this. If I go to, here we go. Hydrogen.
Point something.
Density, vapor density.
0.089.
0.07 approximately, right?
Okay.
So it tells me that it's lighter than air. So that's the first thing we say. Just it's less than 1. You could just say less than 1. And you instantly know it's heavier than air or lighter than air. Flashpoint, you got to look it up, right? You got to actually look it up. So if I go here and I go to this engineering tool density box, probably going to give me all kinds of things about hydrogen. Density, let me see. Let's do this. Let's go NFPA 497 hydrogen gas area classification chart and hit enter. And then we're going to click images. And we should be able to see it right somewhere in here. Maybe right here. I don't know. Can't see it. Let's see if it's here. No, it didn't help us there. Let's type in hydrogen data sheet. Air gas. This will help us. So if you get a data sheet, keep it, right? As long as it's the right data sheet. Sometimes everybody has slightly different stuff. So it's telling you it's extremely explosive. Its hydrogen is 100%. Let's see here. What were we looking for again? I can't remember now.
We were looking for the
auto ignition temperature.
Auto ignition temperature.
Yeah. So if you see here, auto ignition temperature is 500 degrees, 500 to 571, right? So that's what that would be. My lower explosive limit is what? 4%, right? It should be 4%. Let's see. Lower and upper explosive limits
4%.
or lower and upper explosive flammable limits, 4% to 76%. Particle density, don't care because it's not a dust. Ignition temperature. This is your auto ignition temperature. And this is, if I look here, auto ignition temperature is
that's
what?
500 to 571.
Yeah, we already said it. Yeah, that's right. We said it already. So what's flash point? That's a different number. We said it wrong. Oops. Let me go back.
Flash point.
Not available.
Yeah.
So, and it probably is. It shouldn't be available because, what did I do? What did I do right here? Right here. Okay. Because it's not a gas.
Mm.
It's not a liquid, rather. What is its classification?
So in that case, it's gonna be class 1.
It is class 1 because it's a gas, right?
Mhm.
And what's its group?
I mean, from 4%, I can say group A. I can tell that it's group A.
No. Why do you say 4% is group A? It's B. It's B.
Oh, okay.
Yeah, because it's hydrogen. So if I was to fill this sheet out, I would, and I could actually fill it out for a bunch of different stuff. So if I look at this one, it says NEC T code, note 1, National Electrical Code, temperature T code, reference NEC Article 500 5D.
Mm.
Okay, let's do that. 500 NEC 500 dash what? 5D.
Mm.
Let's find it. Let's see if we can find that. And let's go images. Okay. So hydrogen, class 1, group B. Yeah.
ICRI plus H.
Yeah. See. And there's your T.
Mm.
T2 or T1. Which one was it? Uh,
T.
T2. Maybe, I don't
Mhm.
know. Wait, let's see. Hydrogen, class 1, group B. What is this is the minimum, the maximum surface temperature, right?
Mhm.
Remember the auto ignition temperature?
Auto
The auto
ignition
ignition
temperature.
temperature was something greater than
500.
500 degrees,
500, yeah.
right? So it's
Yeah.
a T1. Yeah. So anyway, and I'm flipping around these charts. I should be using actual real charts, right? But
Mm.
you get the idea, right? You would
Yes,
use an
yes.
NEC. Let's see what else we got. So we fill this sheet out, right? And this material happens to be item number 1. So when I go to this sheet, form 2, I say, okay, I'm looking at item 1. I'm looking for what? I'm looking for release points. I'm looking for vents. I'm looking for flanges. I'm looking for threaded connections, things like that. So I say reference number 1, hydrogen, description, a valve,
Mm.
location on a certain drawing. If this was my A's and these were my numbers down here, and it happened to be uh, Z1 or A1, right? And it happened to be right there. That's how I would label that, right?
Mhm.
Grade of release. What does grade of release mean?
The rate of release is
What does that mean? Let's go here. I'm gonna show you something real quick. H drive, engineering, electrical engineering. This is back in 2008. These are PowerPoint presentations I put on back in 2008. Where is it? Kernel training, area classification. Now, if I look at this one and I look at purge technology, rooms, enclosures, let's look at this standard right here. Plus, let's look at this standard right here. Let them open up. And it said, let's do control find, release. Release sources, right? Material sources. Let's keep looking. In table 2, a continuous. Okay, so what it's telling you, is it continuous? That means that it would be, the mixture would happen more than 1,000 hours per year.
mm.
Is it a primary release? Has a mixture of 10 to 1,000 years of leaks per year?
Mm.
Or is it a secondary release? right? So what they're trying to tell you is, they're trying to ask you is, what is that? Is it a class one, div two, class one? So here you'd say grade of release would be, in this case, if it's a div two area, it would be a secondary release.
Mm-hmm.
And then you would have a reference on that. What's your reference, right? And then your operating temperatures and pressures, just because the gas is a certain temperature doesn't mean that they don't heat it up or cool it off,
Mm.
right?
True.
So they could actually run it at a different pressure at a different temperature, right?
Mm-hmm.
What's its state? It's in gas,
Gas or
liquid.
liquid.
Yeah, right. What's its type? So again, you go back to this ELEH11
Mm-hmm.
and it'll tell you the states and everything. And there should be like a definition page on here that I probably blew right past. Let's just see. Hmm, no definitions. But this actually just describes it, right? This actually tells you how to fill that chart out. Material class one, div one, class two, probably in the back of it. Gas detection, undocumented locations. Let's keep looking. This is that flow chart, which I
Mm-hmm.
like. And then here, that's what we're missing right there. One is continuous, secondary, or primary.
Okay.
If it's continuous or secondary, we know it's div one.
Yes.
If it's primary, it's div two. Um, quote from Form 1. So whereas it says here 2 is quote from Form 1. So the reference is item number 1, hydrogen. Uh, 3 is the state gas, liquid gas,
Mm.
solid,
Mm.
something like that. 4 is the degree of ventilation, the type of ventilation. Is it natural or is it artificial, right?
Yes.
Does it have a blower that blows air in there? Or is it like it naturally just rises? If it's
Mm.
artificial, et cetera, right? And then you've got availability. How often is that air there? Is it continuously there? Things like that, right? So if you have, and this steps you through it right here. It says continuous, then it says ventilation high, medium, or low.
Mm.
High ventilation, right, can reduce the concentration of a source of release virtually instantaneously, right? Medium ventilation, and they give you a definition for that, or very low ventilation. Then you've got how good is it, right? Is it the availability, good, fair, or poor, right? How
Mm.
long is it going to be there? So that's the kind of things that this thing helps you define, right? And what
Mm.
it's trying to do is it's trying to define these this gas and its way it's being used. So then you come up with a div one or zero, whatever, right? So
Mm-hmm.
this is just describing how that material is out there, right? So if I have a process vent, and this is just one example, 3 feet or 5 feet from the radius in this example
Mm.
is div one. 15 feet from the radius is div two.
So.
If there's nothing in that area, literally no arcing and sparking devices,
Mm.
nothing in that area to ignite it, who cares? You just note it and move on, right?
Mm.
But if there's something in there, then you got to deal with it. Here we have an inadequately ventilated enclosed area. It is no ventilation in there. They put process equipment in there. They've
Mm.
got this inside this room is a div one area. So all the electrical equipment, including the process equipment, must be ready for div one.
Mm.
The adjacent wall on both sides. I don't know why they didn't show it on both sides. Oh, this one's vapor tight wall. This is the vapor tight wall. This is the non-vapor tight wall. That's why they
Mm.
showed it that way. So if you have a non-vapor tight wall, what would be a vapor tight wall? You know,
Vapor tight wall. Like, is there a wall that can allow vapor to
get through it. It cannot
get
let,
through it?
yeah, vapor can't get through it. Would drywall gypsum in your house be rated vapor tight? Yeah, should be.
Yeah.
Yeah, if you don't see cracks and you see they sealed it with caulk and everything, then it's probably okay, right? That's a vapor tight wall.
Mm,
So if you run into a situation, now the next job is you got to look at every piece of equipment and you got to check to see if it's ready for that environment.
mm,
A lot of times people say, "Oh, it's a valve. We don't classify that because it's in a well ventilated area, right?" Well, I say bullshit to that, right? Because
mm,
it can leak. It will leak. And if it wouldn't leak, they wouldn't put an LDAR on it, a leak
mm,
detection area, whatever tag, whatever it is.
mm,
So if it's got a flange fitting, if it's welded, that's another thing, but it still has a stem. So
mm,
minimum, it's a Div 2, minimum, in an adequately ventilated area. If this same valve was in a inadequately ventilated area in a box, then it would be Div 1. So here we have two examples of the same thing. We've got that valve, process valve, comes up, goes around, it's in a shelter. It's in an adequately ventilated enclosure. That means they really moving air through there, right?
Definitely.
It's Div 2. And if it's the same thing in that building, but they have a vapor tight wall on this side, no vapor tight wall on this side, and it's not adequately ventilated, they don't do a real good job because they really should probably show like a vent on top or something and
Mm,
some vents here where it can blow through. But if it's stuck like that, then it's a Div 1. If you have that after cooler, remember that little we were looking at the first picture of that generator?
yes, yes.
That was after cooler. So that's what that would be. And if you have a flange connection there and that material that's running through there to be cooled is hazardous, that's a Div 1 or
Mm.
Div 2 rather, right? And that's that. That's still my same phone number from 2008, even though I've moved around in the building.
Oh,
Yeah.
yeah, I mean, yeah,
Does that
thanks a lot.
help? Yeah.
A lot. Yeah, I
Oh,
mean, this
good.
time I think I got all the uh like the difference between the divs, the classes, the zones, and so
Yeah.
on.
And
Because last time,
sometimes, you don't want to ask the question because you don't want to slow the class down, right?
that's correct. Yeah,
Yeah. But I encourage you, ask questions, right? Always ask questions, right?
sure, sure.
All right. Well, now you got a recording. So I think that's it.
Yeah, thank you so much for that, and thank you so much for your time.
No problem at all. You take care, okay?
Yeah,
All right. Bye-bye.
bye bye.